every time. And somebody shows up as soon as I click it. Oh, why do you do this to me? All right, good to have you, Manuel. Thank you for coming. All right, we've got a lot to do today. You have a test tomorrow. You had a review. Ideally, you finished said review and you've already turned it in on Google Classroom. It's totally done and completed, right? Yeah, I'm going to assume that is. I haven't checked yet. So today, we are going to walk through said review. I will share with you my answers. We'll attempt to explain them. They should be fairly straightforward, but especially when we get to the last page, there's a little bit of wiggle room. So I'll kind of explain the bounds on that, what would be a reasonable, acceptable answer, and what would not. All right. Before we get to that, a few details on the test itself. It will be done entirely online. It is a Google form. There are 20 questions. I think it's 12 multiple choice and 8 short answer. So you will actually have to like type out your equation, y equals x caret squared, right, whatever it ends up being. Okay. You will be allowed your notes, any and all paper printed notes you can use on the test. So if you haven't already, get hard copies of that. Whatever you have digitally, print it out. It'll be useful for you. All right? You are allowed a graphing calculator or equivalent. So if you have a Chromebook, it has the TI-84 app installed there. If you do not, the next best would probably be Desmos, although getting the tangent line quickly and easily is not as quick and easy on Desmos, I think. So really look over that link I posted several days back when we discussed that feature. There was a link to how to find the tangent line on Desmos. It also has a pre-done Desmos graph set up with the tangent line calculated for a graph. All you got to do is change the equation there at the top. You can use that. I'm allowing you to use that shortcut just because that's about as easy as using the TI-84. Right? Otherwise, other websites or applications or persons or information you are not allowed to use. I think that's fairly straightforward, right? Okay. Any questions about the test itself? No, I think I covered everything. All right. Then go ahead and turn to your review. Here we go. Find the slope of each line. There really doesn't need to be a lot of work involved here. Rise over run.
Apple.
Yes.
We can't see like what you're doing.
Well, that's because I didn't click the thing to make it appear on the screen. Thank you. This needs to change from let's view to let's view. How about now?
Yes.
Aha, okay. There we go. All right, oh, that means you missed the quote. Oh, I'll come back to it at the end. Anyways, slope of each line. Number 1, slope is -1/3. Number 2, that slope is +3. Number 3, that slope is -3/2. Number 4, that slope is +3/2. I did not know that they would just give you positive, negative versions of each one, but there you have it. All right, any questions there? How many questions are there on the test? 20. All right, find the slope going through each pair of points. Now you got to actually do a little bit of calculating, okay? Subtract the y's, then subtract the x's. I almost always went with the second one minus the first and the second one minus the first. You could, of course, swap the order as long as you do it to both x and y. You're okay. So number 9, that slope is negative 4/15. I prefer fractions most of the time. Number 10, that slope is negative 1/14. Number 11, that slope is 3/4. And number 12, that slope is negative 1/4. Okay. Questions there? No. I am hoping that this first page was trivial for you at this point. You've been finding the slope of a line for 4 years now. But it is a very, 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 very common thing to do in calculus. So we want to make sure that's mastered. All right. Now, here's a line. Write the slope-intercept form of the equation. So once again, quickly calculate the slope from the diagram. Find the y-intercept there on the graph. Put the two together. And number 1, you get an equation y equals 2x minus 3. Number 2, y equals negative 2x plus 3. Number 3, y equals 1/2 x. And number 4, y equals negative 2. Questions there? All right, next page. Write the equation in point-slope form from the two given points. So once again, quick calculation of the slope. Pick one of the points. I went ahead and wrote both of them, so whichever one you chose, it should be on my screen. So either for number 8, y minus 3 equals 2 times x plus 1, or y minus 9 equals 2 times x minus 2. Number 9, slope of 1/2. So y plus 3 equals 1/2 of x plus 2, or y plus 1 equals 1/2 of x minus 2. And for number 10, y minus 2 equals negative 3/2 of x plus 1, or y plus 4 equals negative 3/2 of x minus 3. Any questions on those guys? Right. Next up, using the table to find the average rate of change. Average rate of change is just a fancy word for slope of a line between these 2 points, right? So that's all you got to do. Don't be confused by the notation here. I just need a shorter way to write the slope. And I got tired of using m. Right? We could just use m again. But you'll see more delta y over delta x to get towards calculus. So that just the Greek letter delta means change in. All right? So change in y over change in x, which is the formula for average rate of change. All right? So you're just finding slope again of the points given. So from 1 to 3, look on the chart. Here's 1, that's 40. 3 is 18. So you subtract both of those, divide, and get negative 11. For number 14, we get 13/4. Number 15, you will end up with a fraction or a decimal in the denominator, and we can't really have a fraction of a fraction in our final answer. That's generally frowned upon. So now I will go ahead and give a decimal approximation here. 4.118. On that one specifically?
All that section.
Okay. Do you see it now?
Yeah, I know how to do it.
Okay.
I'm confused.
All right. And then 16, similarly, because of that decimal in the fraction, go ahead and get a decimal answer, and turns out it's a nice even 9.2. Okay, any questions from that? No? You're absolutely correct. -7, that'll be -4.18. Get that over. There we go. Thank you for that. Correction, number 15 should be -4.118. And I went to 3 decimal places. That's a good general rule of thumb at this point. If they don't tell you otherwise, go to 3 decimal places, right? Unless you see one that's like really good. It's like, ooh, if this was like 2 decimal places, it'd be right on the money and it rounds up. Like, yeah. 3 decimal places is enough. All right. Thank you for that correction. Any others? Okay. Next up, still finding average rate of change, but now it's of the given function between each pair of intervals. And this one, I apologize, I didn't realize that each question was actually 2 questions in one. They want the average rate of change between this number and that number, and this number and that number for each one. So there's actually 2 calculations for each one here. But it does play into our idea here of getting closer and closer to an expected value here. So for number 17, the first rate of change should be 8.9, and the second one, 1 decimal point more specific, you get 8.99. Number 18, the first average rate of change is 9.1. The second gives you 9.01. And notice we went from 1.9 to 2. We got really, really close to 2, but slightly less than on 17. And on 18, we were just barely a little bit more than 2. So if I were to ask you the hypothetical later coming calculus question of what do you think is the instantaneous, the exact specific rate of change at 2? The slope of the tangent line at 2. What do you think it's going to be based on these results? These are getting really, really close to what number? What do you think? 8.99 is almost, but not quite what? 9, at 9.01. It's really close, but a little bit over 9, right? So when we were on one side of 2, when we were a little bit bigger than 2, our slope was just a little bit bigger than 9. When we were just a little bit less than 2, our slope was just a little bit less than 9. So it's looking like pretty reasonable that, hey, if I was to somehow be able to calculate the exact slope of the tangent right onto, it should give me 9. That's the picture I want to start painting for you here. Right. Anyways, that real calc preview aside, the 2 average rates of change for number 19 are 6.9 and 6.99. And for number 20, they are 7.1 and 7.01. I left out the showing my work on those because I ran out of space on the page. $10? What? No, that's too high. Narrow in. You don't have to round all the way to 10. Yeah, if you're getting 9.01, 9.001, it's like, that's starting to look pretty close to 9, right? The next best integer, 9. We'll see more of that later. Anyways, any questions on these guys? All right, moving on. All right, we've got a very fancy looking cubic function for the cost to produce items. Something, I don't know, manufacturing chocolate bars. I don't cares, right? Doesn't matter what it is. The average rate of change from 100 items to 200 items. So X is going from 100 to 200. So you're looking at the cost of 200 minus the cost of 100 divided by 200 minus 100, right? The change in the Y, or in this case, function C, over the change in the X's. And all you gotta do is plug this number into there, and you get 9,300. Plug this number into there, you get 5,700. Subtract, divide by 100. Your answer should be 36. All right, so go back to these ones, 17 through 20. Right? Finding the average rate of change on an interval for this function. You good with that? Did you see how the formula works out? You find the function of the first number minus the function of the second number, and then you subtract those two numbers in the denominator. So this function was called f. This function was called c. Otherwise, this formula is exactly the same. Function of the first minus function of the second divided by first minus second. What changed here was the function they gave us was much longer. It's now a cubic with a lot more zeros in the numbers. And they were really wordy with how they gave us the interval. Instead of just putting brackets on from here to here, they had to explain in a whole sentence. Find the average rate of change when the total cost, when the number of items produced increases from 100 to 200.
So the 200 you plug it into. Plug 100. So both of these are plugged into that equation.
Yes.
And then this.
Yes. Right. Plug both of them in. Subtract those two. Divide by the difference of the original numbers. And despite the size of the actual results, the actual cost ends up being, several thousand. The change in cost from 100 to 200 items per item, right? The rate of change is only 36. And part B, same process, except now we're given from 200 to 400. So we're going to plug 400 into our function. We'll plug 200 into our function. We'll get these two numbers. We will subtract them. We will divide by 400 minus 200, which is 200, to get 69 at the end. Okay, further questions there? All right, the next one, process is the same, new function. Still talking about cost to produce X items. Still going to take, we're increasing items from 100 to 300. So I'm going to take 300, plug it into my function. Take 100, plug it into my function. Take the difference of those two results, divide by the difference between item numbers. And I get 107 this time. And the second one, now from 200 to 500, putting those in, I get 227. Okay, we're going to be doing this quite frequently this year. Here's a new function. Find the average rate of change from here to here. Here's a new function. What's the average rate of change from here to here? From there to this one. Right. Because calculus is the mathematics of change. That'll be almost entirely, or basically half of the course is finding the change in things. Say again? Yeah, except instead of average, you'll find the instant rate of change, which is the difference between the secant line and the tangent line, right? Well, if you got really, really close and you got exactly on one spot, you'll find the instant rate of change, the slope of the tangent line, which right now we can only do with the calculator's help. But in calculus class, you'll see, oh, and we'll actually take a preview of that at the end of the year, of how we can find it and just compute it ourselves. It's actually not too bad. Calculus itself is not that complicated. The concepts of calculus. You can wrap your head around infinitely small numbers. You can understand the concepts of calculus. The computation, though, usually involves, it only gets messy when the algebra gets messy. So that's why we're mastering these algebra basics. All right. Moving on. As I said, use the calculator to find the tangent line at the specified point. So you will take out your graphing calculator. You will go to the y equals menu. You will type in y1 equals -1. Actually, hang on. I've got extra stuff in the denominator, so you'll actually want to make sure it ends up looking like -1 divided by parentheses x plus 3 close parentheses. Make sure anything in the denominator, you tell the calculator, put all of this in the denominator. Otherwise, it's going to go order of operations left to right. It's going to take this, divide by x, and then add 3. Oh, like your answer? Yeah. Yeah, fractions are fine. This is like 1/10 of 30 seconds, so.
Yeah, it is. I just checked right now.
Yeah. That one's not going to be a nice fraction, but. But yeah, you can do this one as, eighths. That's okay. All right, so you do that. You graph it. You select a window, zoom 6 or standard or zoom fit to see the thing. You at least need to have this number on screen, right? So wherever x equals 1, you have to be able to see that on the graph. And then it's very easy. You go to the draw menu and you say, draw me a, I think it's what, 5? Number 5 on the list, whatever, tangent. And it'll take you back to the graph and say, where would you like me to draw a tangent? And you say 1. You just type in 1, press enter, done. It draws the line. It gives you the equation at the bottom. Couldn't be simpler. Desmos is going to be more difficult, right? Because you have to type this in, one line, And then on another line,
I use a different thing.
right, you've got to tell it, you have to use the actual calculus notation dy dx of f of 1. And then, yeah, so
Yeah, I got it.
it's a little more complicated. As long as you have a method that works. Are some of the questions multiple choice? I said this at the beginning. Rewind the video, go back. Yes, about half of them. All right, so you follow that process, and this is what you get. Again, this is the closest decimal approximation the calculator gave me. You should have something pretty darn close to this. Number 3 then, 0.375x plus 0.125. I think on the calculator screen it was like 0.12500000001. Something like, it does that. It's odd because it's off by the location of the actual pixel. And a little bit of rounding error in the calculator's process. So go to the most reasonable number that doesn't have all this extra 0.00001 off the end. All right. And then similarly, number 2, yeah, I definitely remember this. The calculator did not just say -9. It couldn't leave well enough alone. It said -9.000000001 x minus 1.9999999999999. I'm like, okay, that's basically -2. Right? If it gets out 6 decimal places, you can safely round that and be like, oh, something messed up. It's off by a pixel, rounding error. Okay. Go to the next whole number, please. This one might have really thrown you off because the slope is in fact 0. It's a flat horizontal line at that point. So you should just have y equals, this is where I went back to fractions, because otherwise this is 4/3 would be -1.3333. Repeating. You see repeating 3s or repeating 6s, you don't round them. Turn it into thirds. Okay, that's your rule of calculator decimal interpretation. If you see repeating 0s and a 1 on the end, round it down. If you see repeating 9s, just round it up. If you see repeating 3s or 6s, turn it into a fraction over 3. Other repeating numbers, I'm not sure. There's not really a good rule for repeating 8s. I'm not sure about that, Ruby, if the school had to pay for the Chromebook calculator app or not. I know Mr. Beagle was able to install it this year. I don't know how he did that, if that's actually a free app. I imagine not. Not likely. Probably did pay for a license at some point, but I haven't asked. All right. Any questions about this process? Okay. Yes. Say no. Oh. You want to go on. You're taking forever. Okay. I know. The good stuff is never free. It's not free. Next one? Okay.
I'm kind of slow. I thought we were trying to identify what the graphs were. So like
Yeah?
absolute value,
Yeah.
tangent line. So I didn't do that.
You didn't have to do any tangent line or anything. This is just graphs and their transformations.
So like,
So first one was identify the parent function. What type of function is this? Oh, this is a parabola. It's y equals x squared.
I said quadratic. I have to change the equation.
I said the parent function, which would imply y equals some, or f of x equals x squared. I mean, for this, for the review, that's fine,
For the test.
right? On the test, yes. If I say identify the parent function, I'm asking for an equation.
Okay, I remember that.
Function is our new fancy word for equation. Right?
With that, when we did that little graph thing.
Yeah. So if I say parent function, give me an equation. If I say type of function, then you would just say, and I think that was like the table we filled out, right? That'd be more name. Like this is the type of function. Oh, it's a cubic function. It's a linear function. Good question, though. Thank you. All right, so first was identify the parent, and then identify what transformation this one had. So this is an x squared function. It's been shifted to the right about 2 units. You really got to zoom in on here, and I apologize for that. If your count is a little bit off, because it's very teeny tiny bits on there, totally accept that. But you should have at least been able, it is shifted to the right something. We can at least agree on that part. So your number here does not need to be as precise. All right, next up, this is a sine function. We'll do trig functions in depth next semester, but sines start generally in the middle. Okay, we've got kind of in the middle of a curve here. That's how I know this one is a sine, versus this guy is a cosine because it starts, right, the y-axis is on the top. If it starts at the top of the hill, it's a cosine. If it starts in the middle of a hill, it's a sine. And by start, we always mean where the y-axis is. Okay, so this one has been shifted down. This one was shifted up. At the very least, this number should be bigger than that number, like relatively speaking here. All right, this guy does almost nothing for an eternity and then suddenly takes off like a rocket. That's an e to the x, exponential growth right there. Usually the takeoff starts happening right on that axis. So this has been shifted to the right, I would say about 6. And this one, that flat part has been shifted up. Okay, these guys, it's kind of hard to tell the difference between part of a square root function and part of a logarithmic function. But I'm going to insist that these are square roots, not logs, because they don't have the tail. Right? A log is an inverted exponential. It still has this gently sloping curve to it, but it has the tail on the back side where it drops straight down. These don't have that. So these two are square root graphs. This one shifted to the left. This one shifted up. Okay, then we have another parabola, shifted down this time. And finally, 2 absolute values. V guy shifted to the left 6, and this one down about 4. Okay, other questions from that section? All right. Now we start getting into tougher territory. Maximum and minimums. How does the transformation depicted as an equation of just f of x? They don't tell you the function. You could describe the function. It's clearly some kind of a cubic thing, right? But we're not given the actual equation. We're just said this is f of x. What happens to the max and min if I did f of negative x? Well, f of negative x, well, that's going to be a horizontal reflection. Left and right are going to switch. So negative 5 comma 10 becomes 5 comma 10. It's still the maximum. It just moves over here. This moves over there. Negative 1, negative 8. Y equals f of x plus 2. Take the original function, add 2 more. You're just going to move the y values up 2 higher. So 10 becomes 12, negative 8 becomes negative 6. F of x minus 2, horizontal shift to the right 2. Remember, it's opposite sign. Oh, negatives are on the left-hand side. Oh, but it's x. Negative means it's moving right. Okay, so instead of negative 5, you go over to negative 3. Positive 1 becomes positive 3. And finally, y equals negative f of x reflect vertically, flip over the x-axis, up becomes down, this moves down here to -5, -10, and it's now the minimum. This moves up to +8, now becomes the maximum. Questions on that one? Next one, same but opposite. They give you the new max and mins, you find the transformation that caused it. So to go from 218 to 318, we just had to move to the right 1, which means x minus 1. To go from 218 to 223, we added 5 to the whole thing. So +5 outside the parentheses. To go from 218 to 518, we needed to move to the right 3. Similar to this guy, just different number. And to go from 218 to -118, we're actually moving to the left now, so x plus 3 inside parentheses. All right, next page. Complete the table of polynomials. Yes, all of these can technically be classified as a polynomial, even this guy. So in standard form, just put the highest power first. This one switches places, that doesn't move. 5x comes in front, and the -6x cubed comes in front there. They are degree third, 0th, although we almost never say that. I would never ask for the degree of a constant, but there it is. Right, first and third. Number of terms is just how many items are added and subtracted there, 2, 1, 2, and 3. And so equation 2 is a cubic binomial. 3 is just a constant. 4 is a linear binomial, and 5 is a cubic trinomial. And even this is like, you almost never say linear binomial, because linear can only be binomial or monomial. It's never going to be more than that, right? Can't have more than that. And so this is just the most common form of just linear equation. So rarely call it out as a binomial, but technically it is. That's the full name. Most people just use the nickname, just call it linear. Any questions there?
On the test, what if we just put like linear or and we don't put like
It depends on what I'm asking for. So the name of the function, especially they prompted you with an example here that says, hey, we're using the 2-word name, then you'd be expected to use both words. If it just asks for type of function, you could say this is a cubic function. Okay? Or what's the degree of this function? Right? You could say 3rd degree or call it cubic. Okay, so more than likely, yes, you can use the short term. It depends on how the question is set up. Again, rarely do we call out these as, oh, this is a cubic trinomial. This one's only a cubic binomial. It makes a difference when you start like multiplying them together and you have to distribute things. Certainly, they are different. But rarely do we feel the need to name them each time. Especially when we get towards calculus, the number of additional terms literally doesn't matter. We're talking about reaching out to infinity. When x is several million, okay, none of the other terms matter, only the biggest one. So we really don't care about the rest of them. I don't care. Look, it's degree 7. That's the important part. If it's a degree 7 binomial or a degree 7 quadrinomial, it's not going to make a difference when x equals 1 million. that second term becomes less and less important as we go. I don't think I have a question that is just name this function on there. I'll double check that. All right. Identify the best graph for the function. So here we're looking at, I'd say three things, three features. First, the degree. Okay, this guy is cubic, which means the ends go in opposite direction because it's odd. Okay, so immediately eliminate B. That can't be it. It is negative in front, which means when x is positive infinity, it's going downwards. So we can immediately eliminate C as a possibility. And now that leaves us with A versus D. They look at a distance pretty similar. I mean, in shape and direction of the end behavior and all that. So in that case, we want to look at the very last term, the -1, because that is going to still be our y-intercept, just as it is on our linear and quadratics that we're more familiar with. So the whole thing has been moved down 1. So the fact that this guy still goes through the origin means it can't be A. That origin piece has to be shifted to have a -1 y-intercept. All right? So there's three things to look for to find which graph it has to be. Number 1 has to be D. Number 2 has to be C. The only thing that goes same direction, both down, and has a negative y-intercept. Yep. And now we get to the tricky business, right? Two of them?
Didn't take way too long.
I'm gonna say maybe just one.
One. This is easy to do, but it's so tedious.
But it's not supposed to take too long, right? This is why we practice this, right? You want to get fast with it. Most of this, you should be able to identify quickly enough. At least on the graph, you can point to, all right? Right? You should be able to immediately look at this and say, that's 4th degree, okay? I go up, down, 1, 2, 3, 4 sections, 4th degree. Okay? Technically, it is at least 4th degree. There could be other higher degrees that still mimic this, but it's a minimum, it has to be 4th degree. Both of them are going downwards, which means it has a negative leading coefficient. That's immediately obvious just from looking at the shape of the graph. Okay? It requires very little interpretation, very little brain power dedicated to this part. There should be very little brain power required to find and point to the maximums here and here, and the minimums there. What will take longer, yes, is now, okay, you got to read the graph and figure out, okay, what's the actual coordinates of these points. I totally agree with you on that one. That takes a little while, especially some of these graphs, not the clearest. I apologize for that. It's very hard to find a good variety of polynomial graphs. Yeah. So what we've got here is the coordinates there of the maxes and min. Where is it increasing? Where is it decreasing? Again, you should be able to look at that, right? Wherever there's a max or a min, that's when it changes from one to the other. So before that maximum, it was increasing. Now it's decreasing. Now it's increasing. Now it's decreasing, right? If I could give you a test and asked you, like you had this app, and I could say, highlight where it's decreasing, highlight where it's increasing. I wish, if I had the technology, I would. Unfortunately, I cannot administer a test with this tool built in. I haven't found that yet. Yeah, that would be the next thing. You should be able to look and see concave up is, let me get a slightly smaller highlighter here. About there, right? Kind of halfway between your maxes and mins. And then down would be the rest of that, and all the way out to infinity, and all the way out to infinity. So there's your concave downs. All right? So finding those regions in the picture, I hope that part is fast. What slows you down is getting the actual coordinates. All right? So my answers are here. Your answers, especially when we get to the decimals, might be off a little bit. That's totally acceptable. This guy goes up to 8, so it's 2, 4, 6, 8, which means halfway between the lines are like 1, and so this is maybe like 1.5. A little more, but not quite. Yeah. All right. We're over time, aren't we? Yeah. Okay. The rest of these are posted. All right, you can see them all there. It is a digital file. Feel free to zoom in. Let me know if you have any questions on any of these guys. I hope I've at least outlined it for you. You can zoom in and compare your specific answers. Okay? Again, don't get too caught up on the actual decimals. All right?
Test is tomorrow.
Test is tomorrow.
When? During our period?
During class period. Yep.
What is it on?
What?
What is the test on? Where is it on?
You'll log into Zoom, and I will send you a Google form. Yes. All right. So long, farewell. Enjoy the rest of your day.